What's up? Welcome back to linear algebra. Let's jump into Augie. Alright, one flashcard. What three basic algebraic operations can you perform on the equations of a linear system without altering its solution set? You can multiply an equation through by a non-zero constant. You can add a constant times one row, non-zero constant times one row to another row, and you can interchange two rows. Or two equations, I meant. Good. All right. I'm going to grade what I did yesterday, and then I'll be back to recall what I got right and wrong after that. All right, I got all the problems right from yesterday. So now I'm going to go ahead and continue doing more problems, and I'll be back in a bit. All right, so went back to 1.2 to do a review problem. Basically solve this linear system by any method. I basically just instantly said infinitely many solutions because it's a homogeneous linear system denoted by the zeros as the constants, and there's more unknowns than there are equations, so we know there are going to be free variables. I believe that means we have infinitely many solutions, but we're going to find out tomorrow. I believe that's how you know that right away. This problem was basically saying determine whether the inverse exists using the theorem we learned last section, which is to find the determinant, make sure it's not equal to 0, which it wasn't, so the inverse does exist, A is invertible, and then use this same theorem essentially to solve for the inverse. There's the inverse of A. 14, basically this one got a kind of dirty with the numbers or messy, so I don't know if I did something wrong or if it's just that's how it is. We're going to find out when I grade it tomorrow, but we're given this 3x3 matrix, solve using the inversion algorithm. So we partition a identity matrix, and then we basically whittle this one down to the identity matrix itself, doing the same elementary row operations to the other side while doing it, and eventually get this as the inverse. So as you can see, like this top left hand, like row 1 column 1 is negative 12 over 12 times the radical or square root of 2 plus the square root of 2 plus 1 over the square root of 2. So I'm like, did I do something wrong algebraically? Maybe. We're going to find out tomorrow though. And then 20, I just started. This is also finding the inverse using the inversion algorithm, except for the difference being that the matrix we're given at first is unknowns, not actual literal values. So working through that will actually should be pretty simple, but finish that one tomorrow. Yeah, we're on question 20. We're going every other even right now as the second pass. 20 will be done tomorrow. We'll have to do another proof. Yeah, we'll do another proof. One other problem, and then maybe one more true or false. So probably we've got about a day left plus a proof, which probably will take a day. So 2 more days, and then we'll probably be into 1.6. Start looking at what that's about. More linear systems and invertible matrices. Okay, invertible matrices, that's pretty simple. I think by now. We're coming back to linear systems. It's been a while. We've been mostly focused on matrices, so we're coming back to linear systems again, so that's interesting. Really short chapter though. 5 pages of basically new information and then back into problem set. So a really short problem set at that. So yeah, talk to you later or tomorrow. See ya.